Welcome to the next video in the Suggestion app course. This is a complete course where we'll build a .NET 6 Blazor server application with MongoDB from the ground up. There are 3 things you need to know before we get started. First, this is part of a series, and this isn't the first video in the series. If you're just starting out, you should check out the playlist that's linked in the description to start from the first video in the series. Second, this course is actually a paid course. MongoDB sponsored it so you can put the videos on YouTube for free. Check out the link in the description to sign up for MongoDB Atlas for free to thank them if you haven't already. Third, you can also buy this course on IamTimCorey.com. The link is in the description. Buying this course will get you all the lessons right away, the source code for each lesson, a certificate of completion, offline access, and more. It also helps sponsor more free content. The video will be the same as it is on YouTube, so feel free to watch the free version if you want to. Okay, let's jump into today's video. Note there may be more than one lesson in this video, since some lessons are short. We've saved the best data access for last. So let's right-click on our data access. We're going to say add new class. We're going to call this MongoSuggestionData. This is the primary collection for our data. So it's going to be a primary place we're going to do all the work. Let's get rid of our usings and make this public. And now in here, we're going to need quite a few things. So let's start with our constructor. We're going to ask for the IDB connection, DB, IUserData, and iMemoryCache control dot to add that using. We'll call this cache. Now we need to actually capture all of these, all 3 of these. So yes, this is different than normal. So we hit control dot to create and assign a field DB. Come over here to user data and do control dot to create and assign a field for user data. And one last time for cache. So now we have all 3 of those. We also need to have our private read-only, and this is going to be our iMongo collection suggestion model. And we'll call this suggestions. And we also have our private const string cache name of suggestion data. So, and actually my constants should be capitalized because they are constants. So that should be cache name like that. So let's go back and change that in the other ones as well, just to be consistent. I always forget about constants. So I'm going to control, actually, I believe it's control R. So we're going to paste the new name in there, control dot, there we go, rename. So we're going to rename it everywhere. We'll do the same thing for user data. We'll replace it. Oh, user data doesn't have it, sorry. So category does though. So we'll paste in the new value, control dot on it to rename it everywhere it's used. And that takes care of that. So now we have our cache name properly capitalized. You can come down here to our constructor and say suggestions equals db.suggestionCollection. And now we have all our setup done. So we're going to add in the IDB connection. We're going to capture that for use later as well. We're also going to get the IUserData in order to make some calls to our user data. And then the rest is pretty much the same. So let's start with public async task of type list of suggestion model, and it's GetAllSuggestions. And then in here, the same basic pattern. So var output equals cache dot get a list of suggestion model cache name. And then we're going to return output. But in between, we're going to say if output is null, then var results equals, and this is the same pattern we've done before, await suggestions dot find async. Only this time we're going to say where s.archived equals false. So we're limiting what suggestions come back in the get all, which does seem a little odd until you think through, well, what do you want to represent all? Well, all are all that are not archived. Now, we might want to continue to modify this and continue to shrink this down to say all suggestions who aren't archived or who aren't rejected, and so on. But we'll start with just archived. And we'll say output equals results to list. And of course, don't forget cache.set cache name output, and then that time span dot from minutes, not days. Absolutely not days. I'm going to start with 1 minute. We can change this as we go. We could put these times somewhere else and then bring them in, but we're going to just start from this as it is, and we're going to start with 1 minute of caching. This is the suggestion list. We do not want the suggestion list to be cached for a very long period of time because suggestions will be changing. However, it is going to be the biggest list with the most data. So we don't want to retrieve this all the time live from our database. Therefore, we're going to hit a happy medium and say, hey, archive or cache it for 1 minute. What that will do is if we have a lot of people hitting the site all at once, they're going to get the cached values every minute. But after a minute, there'll probably have been a lot of work done where people upvoted things or added new suggestions and so on. So it's going to get that new list every minute. So it's a balancing act we're going to hit. We could extend this to 5+ minutes, and really we could extend it even further if we wanted to because of how we're going to do some cache invalidation. And we'll talk about that in just a minute. But I think for now, this is a good starting point for our system. Remember, we don't want to prematurely optimize. That does not mean we don't want to optimize our code. But what it does mean is that we don't want to spend a ton of time worrying about a little detail that might not matter. So we're going to try and get our best guess as to how to make things optimized and then leave it there. We're not going to make complex changes to our system to optimize what might not be a problem. We'll leave it as is and then say, okay, we need to dial this in further once we get it into a place where we can test it under load. Okay, so that's the GetAllSuggestions. Next up, public async task list of suggestion model. And this is going to be GetAllApprovedSuggestions. So this is not just all the suggestions, it's just all the approved ones. These are the ones we're actually going to see on that homepage. var output equals await GetAllSuggestions. So no need to worry about making a different, the same code again. We'll just call this method. That gets all the suggestions, but this list then we can say return output dot where x dot approved for release, and then we'll say to list. So what this does is it says, hey, give me all the ones that are approved for release. All right. So that means all the ones that are not archived, since that's the GetAll gets the ones that are not archived. And then down here, we filter even further to say only those that are approved for release, send those as the output. So that way we can reuse the same cache, but this time just get the list that the users want to see. Sometimes we'll need all suggestions, but in this case, we just need the approved suggestions. Therefore, we'll use that list. Next up, public async task suggestion model. Get suggestion, and we'll pass in a string ID. var results equals await suggestions dot find async s equal or arrow s dot id equals id. So this is going to do a fresh lookup when you're looking up one suggestion. We're not going to go to the cache for this. We're going to go directly to the database. Again, this is the balancing act where I think I want to have the latest and greatest information always when you're asking for a specific suggestion. But if we find that this is a stumbling block, for whatever reason, then we'll say, okay, let's go to the cache instead. But the big deal with the caching is not about talking to the database. The big deal is about loading all of the data into memory. When we have 5,000 suggestions, that'll be a lot to load into memory. Whereas one, no big deal. So therefore, we'll get that directly from the database, and we'll return results.firstOrDefault. So that's going to get us our one suggestion. So if you ask for a specific suggestion, you'll get the actual version from the database. Next up, public async task list suggestion model. This is getting repetitive, right? Get all suggestions waiting for approval. And yes, it's a long name, but it tells you exactly what it's doing. So you don't have to question what's going on here. var output equals await get all suggestions. Just like before, return output dot where x or arrow x dot approved for release equals false and x dot rejected equals false to list. And again, we'll unpin this so you can see the whole thing at once. And I'm going to make this a little bit better, more readable. So let's go ahead and do this and this. Okay, so what this does is it gets that same all suggestions list and says, hey, show me the ones that are not approved for release and who are not rejected. That way, we can know here's all the suggestions that are awaiting approval. So they've not been approved and they've not been rejected. Therefore, that list is the waiting for approval list. But again, reusing the same cache over again, as opposed to generating a new one every time or using that same code over again. Next up, public async task update suggestion. Suggestion model, suggestion. And we're going to say await suggestions dot replace one async, where our suggestion dot ID equals our suggestion dot ID, and we'll pass in suggestion. So this is going to do a full replace of our suggestion. So when you say, hey, I want to replace this one, here's the new version, that's what that'll do. And then this is the tricky bit you have to think through if you want to do or not. And I think I do at this point, because of the fact that I am not yet concerned about thousands of users. Once I am, I will put some different logic in place. but it'll be much more complex logic. But for now, I'm going to say cache.remove cache name. And what that does is it destroys our suggestion data cache. Because I have just updated a suggestion, therefore I want to destroy the cache so that the next time a person asks for the suggestion data, they get the fresh version which gets cached, which will include this update. Now, again, that means that especially when the site is being actively used a lot, we're not going to ever hit our 1 minute of cache timeout, which is why I say it could probably make 5 or 10 minutes if we do it this way, because of the fact that we're not going to hit that timeout because every time a person makes a change, we're going to remove the element from the cache. So with that, that's update suggestion. Let's now go to another similar one, but different. And that is public async task UpvoteSuggestion. Now this may sound simple, but I tell you what, it is not. String suggestion ID and string user ID. Why those two values? Well, this is the unique identifier for the suggestion you want to upvote. This is the unique identifier of the user who is doing the upvoting. That's all the data we really need. But now I'm going to say var client equals _db.client. Using var session equals await client dot start session async. And this is going to create a transaction for us, which will allow us to make sure that when we write to two different collections, that the write completely succeeds or completely fails. And the reason we have to do two is because we want to update the suggestion to say, hey, this user just upvoted you. We also want to update that user to say, hey, you upvoted this suggestion. So session.start transaction. All right, this starts the transaction. Now we can do a try catch. And for right now with our catch, we are going to not do a whole lot. We're going to capture the EX, but again, in this minimum viable product or MVP / version 1 of the application, I'm not putting logging in. I'm just trying to keep it a lot simpler in order to get through and focus on the main content, which is MongoDB talking to Azure Active Directory B2C and talking to Blazor Server and working with those 3 major hitters. We're not going to focus on logging for this course. I would put logging right here. I'd be logging this to wherever I'm going to log stuff to in order to capture that we had an exception. We're not going to do that. But I will say await session.abort transaction async. I do want to do that. So I'm not using this exception right here. I am going to throw it up to the next level up though. Just so you know that this upvote suggestion, if it doesn't work, we're going to have a exception go all the way up to the caller. I do want that. I don't want to just eat the exception and say, hey, you thought you upvoted, but we didn't tell you we didn't, but we didn't. So I'm going to throw the exception all the way up to the caller. Okay, inside the try. First thing to do is say var db equals client.getDatabase and say db.dbName. That's why we have to expose the database name so we can figure out how to connect to the database using the same database. So that's why we expose that property. Now, again, we have to use this client, the getDatabase, instead of using the database that we created inside of our _DB, because of the fact this database is created using the client that is using the session. That's why we have to create it over again. Var suggestions in transaction equals db.getCollection suggestion model, like so, and then underscore db.suggestion collection name. And then var suggestion equals, let's wrap this in parentheses, await suggestion in transaction, find async, s arrow s.id equals suggestion ID. And then we want to make sure that we get the first one. Now, we could say first default, but we don't want to do that because I want to throw the exception. So if we don't find a suggestion you're looking for, and that's what this is doing, is looking for the suggestion ID you asked for. If we don't find that, there's a problem. So if I say first and don't get any, that will throw an exception. First or default will not throw an exception. It will just make this suggestion null. That's not okay because we can't upvote something that does not exist. So I wrapped this in parens because of the fact that I wanted to await it and then at the end of that say dot first. It makes for a more compact line instead of having multiple lines and variables. Next up, bool is upvote equals suggestion.uservotes.add user ID. Now, what's going on here? This is actually really cool. So the user votes is that hash set. Remember, the hash set does not allow duplicate entries. So when you say add, it's going to add or try to add the item, and if it succeeds, it will return true. If it fails, it will return false. So if it fails, it's not an upvote. So what's the opposite of upvote? A removal of an upvote. So if is upvote equals false, meaning you've already upvoted once. So we're going to remove it then. Suggestion.uservotes.remove user ID. So we're going to try to add the user ID to the list of upvotes. But if they've already voted on it once, then it's essentially the same as removing your vote. What the UI for this will be is there will be an arrow that points up. You click on it, and now you've added your vote. But you go, oops, I didn't want to do that. You click on the arrow again, it will remove that vote. All the same logic, it's just this little bit right here that will change your upvote to a remove. Okay. Now, await suggestions in transaction dot replace one async, where the s.id equals the suggestion ID, and we'll pass in the suggestion. So now that we have updated our user votes column, we can replace the suggestion that we've got with the new version we just changed. Var users in transaction dot replace one, var users in transaction equals db dot get collection user model underscore db dot user collection name. So that's going to get the users that, or the user collection for our users. So var user equals await user data dot get user. And here we're doing a bit of a shortcut because we're actually calling the get user method, which we already have written, but this will allow us to get this quickly. Suggestion dot author dot ID. So we've already written this get user once for here, so therefore the lookup, not a problem to do this outside of the normal, calling the collection and doing it that way. We could go over and basically copy the code for user data. If we find it's a problem to do that with the transaction, we can do that, but we already have the code written, so we'll just call that. So now we can say after this, if this is an upvote, so whoops, it Intel code actually filled in for me. So is upvote. So if it's an upvote, then what we want to do is say user.voteOnSuggestions.add new basic suggestion model, and we're going to pass in our suggestion. So remember the vote on user suggestions takes a basic suggestion model, which we don't have, but we do have a suggestion, which is a full suggestion model. That's why we have this conversion. Passing it into the constructor gives us a new basic suggestion model. Now, why do I say is upvote here? Well, because we're adding to our vote on suggestions. However, else user.voteOnSuggestions.remove new basic suggestion model suggestion. The only problem here is we're creating a new instance of the basic suggestion model, and that's not a record where we can do a comparison of the values. It's a class object, class instance, which is going to do a comparison upon the basically the reference to our class. So instead what we're going to do is we're going to say var suggestion to remove equals user.voteOnSuggestions.where s.id equals suggestion ID, but not first to default. Again, we're just going to say first, like so, and that will give us our suggestion to remove, and we'll then remove that element. So we're going to remove that one from the list, and then once we're done that, we're going to say await users in transaction, replace one async, where u.id equals user.id. We're going to pass in our user, and then we will say await session.commit transaction async. And then the final piece of the puzzle here is to again do the cache.remove cache name. Because again, we want to reset that cache if you are if you've upvoted something. Otherwise, you might upvote something twice because of the fact that you don't realize you've already upvoted it successfully because the cache hasn't been updated. Now, that's going to be not very efficient at first, and it might not be efficient in the long run either, but once we figure out how efficient it is and what we can do about that, we could potentially write some code to make this better. But essentially, if you upvote something, we're going to remove the cache so that the next time you ask for the list, you get a fresh version from the database, and therefore you have those upvotes in the list. So just note that, yes, we're going to have more cache hits the more people upvote things. But upvotes aren't going to happen every minute even, probably, once the site gets running. It's at the very beginning, we'll have a lot of work against it, but it'll also have the least amount of data in it. And then as the site is starting to be used, it will stabilize into a better rhythm. But it will have some spikes as, let's say, I promote it on YouTube or something else. That will cause a spike of people hitting it. Therefore, we're going to watch those spikes and see, hey, how can we make this better at that point? So with that, that is our caching. Now we can do is we move on to the next section, next method. And that is the CreateSuggestions. So public async task create suggestion model suggestion. And we'll have, again, a transaction here because of the fact that the user is going to be creating this. Therefore, we're going to update their user account. So var client equals db.client using var session equals await client.start session async. And then session.start transaction. We have our try, and we'll again capture the exception. And then down here in the catch, what we're going to do is say await session.abort transaction async. Again, we normally log this exception, but we're not going to. Var db equals client.getDatabase db.dbName. Var suggestions in transaction. This is the same thing as before. So let's just grab that line here. Suggestions in transaction, we'll grab that. And we'll come down here and paste it. Kind of saving some typing there. And then await suggestions in transaction dot insert one async suggestion. So it's going to insert our suggestion into the suggestion table. Var users in transaction equals db dot get collection. I'm already halfway into this, so I'll keep going. I could have copied it. User model db dot user collection name. Var user equals await user data dot get user suggestion dot author dot id. And then user dot authored suggestions dot add, and this will be a new basic suggestion model with the suggestion in it. And then await users in transaction dot replace one async. And I got a bug here. Oops. There we go. Replace one async, and then u.id equals user.id and pass in the user. So we replace that one user now that we've updated their authored suggestions to add a new authored suggestion to their list. And then we need to await session.commit transaction. Now I am not at this point, transaction async. Now at this point, I'm not going to invalidate the cache. And here's why. When you create a suggestion, that is not going to the list that users see. Therefore, I don't have to worry about updating the cache or removing stuff or removing the cache because you're not going to see it either way. Even if I replace the cache, it's going to have the same values because you're not going to see this until a user from an admin goes through and approves your suggestion. Therefore, we don't have to update the cache. This does mean admins will not see your suggestion for up to 1 minute. I'm okay with that. That's to save performance as much as possible. That is totally fine by me that admins don't see it for up to 1 minute because of the fact that admins aren't going to be in there every minute refreshing. We're going to be doing other work, and we'll get to this, a few times a day, potentially, maybe even down to 1 time a day. Therefore, having to wait a minute is not a big deal. So with that, we now have completed the CreateSuggestion method. Now let's collapse these down into just their outlining. Let's collapse the definitions so you can see the different methods we've created. We have our constructor. We can get all the suggestions. We can get all the approved suggestions and all the suggestions we're waiting to approve. We can get a specific suggestion. We can update a suggestion, which is going to be more than just upvoting, because upvoting is separate. That's a little bit more specific. And also we can create a suggestion so you can create a new one. That's all we have for our class. That's all the methods we're going to use in version 1. So now we have all that done. Let's go to the class name, hit Control Dot here, and say extract interface. Be a lot of stuff in here. That's okay. I keep the default, which is everything gets checked, because that's what I want to expose in my interface. I'm going to take off Mongo. So it's going to be iSuggestionData. Hit OK. And now we have our interface. So with that, we now have all of the data access for our entire project, our entire solution, actually. So that's all the data access we need for version 1. That's not a ton. If you look at the number of methods and even the number of lines of code, this is the biggest one. We have 135 lines of code in here that represents our massive major data access. The other ones are a lot smaller. We're down to 35 lines. This one is 40 lines, and status is 35 as well. Yep, they're both 35. So we have a couple hundred lines, 250, 300 lines of total data access code, and that's it. Okay, so before we move on, though, what we're going to do is we're going to add all of this to dependency injection, which is why we're using our interfaces for everything. So next we'll add this dependency injection, and then from there, we can start seeing how it actually works and using it to make sure that all this code does, in fact, work against our database. Now that we have our data access done, let's close all the tabs, and let's go over to our UI project, go down to register services. In here, we have to add some more services. So let's say builder.services, not add MVC, services dot, and I want to add a singleton for IDB connection. And that's that DB connection, which has our connection to our Mongo database that we want to have right now as a singleton. If we assign later, like I said, where we have to have it once per user, we would add instead of singleton, here what we do is we'd add scoped. So we'd say add scoped. And that would change it to be essentially a singleton per user. So we can change this very easily if we need to. So for right now, we'll create a singleton, which is one database connection for everybody to use. You don't want to do it from very many things, especially if they share data, which this one does. But this allows us to do exactly what we want to do, which is everyone uses the same database connection. Just be careful that with sharing data. Builder.services.addTransient. And this is going to be category data. Category data. Category data. Oops, not category data, Mongo category data. Now, transient, let's go look at the category data real quick. So the category data here, this has access to the cache, and it has the cache name, and it has access to the collection. All these things are things that are not unique, meaning we don't have to worry about even sharing across users. So we don't have to do transient, in which case what we could do is we can change this from transient, which is create a new instance every time we talk. We could be a little bit more restrictive or a little more reusable and say add singleton if we want to. That will work here as well. We have to make sure that if we do, that we change this to add scoped if we change this IDB connection to add scoped. So we want to make sure we're reusing things in a smart manner, but we do not want to have cross-contamination between users where we're storing data, for instance, the user data. If we were storing anything in here about the actual specific user, that would be a problem because of the fact that multiple users would use this if we're using a singleton. But all we're storing here is that collection, which already is a singleton. So therefore, we don't have to worry about making this a singleton as well because it's not otherwise storing any data. It's just data calls. So it's all self-contained in each method. Therefore, we can create this as a singleton as well. So we can keep going as singletons. So let's copy this line here. It makes it easier. Add singleton. And this will be iStatusData. And it's MongoSuggestionData. And then let's say the next one is iSuggestionData. And that's MongoSuggestionData. And the next one is iUserData, and that's MongoUserData. And notice how IntelliCode really anticipated what I was needing and went ahead and gave me a suggestion for it. So those are now the references that we'll need in our Blazor project to get that data. And also note that each of these four, iCategory data, iStatus data, iSuggestion data, and iUser data, they all rely on IDB connection. So that's another reason why we have to have all of this in dependency injection. They also rely on the cache, which comes from this line right here. So it's important that we use dependency injection so we can properly send all of this data where it needs to go in the right manner, as in this case, singletons. So that's how we configured our dependency injection. Now we can start using this in our Blazor server project.